Hi, my name is Lee Bullock. As you know, together we provide service for Amtrak customers.
And I'm Doug Sizemore. We're here to talk to you about a powerful change at Amtrak that will help us meet our customers' expectations.
There are several parts of this decision we'd like you to know more about. These locomotives are more powerful, and we'll need fewer of them to handle our larger trains. The locomotives are also more fuel efficient. That lowers our operating costs. The locomotives also have extended warranties on both the P40s and the P42s, and that will lead to increased reliability and improve on-time performance and increase customer satisfaction, and that's crucial to our survival.
Amtrak faced a decision. We could buy for the future or build with old technology. We could remanufacture the F40 locomotives, spending millions of dollars, and extend the life approximately 10 years. At that time, we would have a fleet that would be 30 years old, it would lack the efficiencies of modern units, and it would not incorporate all of the safety features.
Better braking control and a more powerful prime mover will assist with proper handling of the train. These locomotives also have some of the most sophisticated technology available today.
So a decision was made to add to the General Electric fleet and place an order with GE to purchase 98 new P42 locomotives. This would be in addition to the Genesis fleet that was purchased in 1993. These locomotives will carry us into the 21st century.
These locomotives represent a huge investment in passenger rail service in the United States. They also reflect Amtrak's commitment to long-distance trains. They will improve our safety, they will lower our operating costs, and they will improve customer satisfaction through increased reliability.
And while these P42s at first glance might look like the P40s, we have been talking to and listening to the engine train crews. While every idea could not be incorporated, many were. We now would like to talk about those improvements that are on the P42s and will be put on the P40s when they are shopped in the future. Some of those improvements start on the outside of the locomotive. You will notice a change in the steps. On the inside of the locomotive, we have improved cab lighting around the desk and on the floor. For the computer, there's been a visor added, so the computer screen will be more visible with different lighting conditions. The computer has upgraded software that makes it more easy to interpret and user-friendly. The air conditioning and heating is thermostatically controlled, and the vents are adjustable. The seats have more adjustments. This locomotive incorporates many of your suggestions, and it will be upgraded on the P40s when they are shopped in the future.
As many of you know, the F40 has been the face of Amtrak for a long time. It's the image people often think of when they think of our trains and our locomotives. That's not surprising because these locomotives have been with us for a long time. Unfortunately, these locomotives in many ways are worn out.
And that's why we have made this video training series with GE Transportation Systems. We want you to know how the P42 works, why it works, how it works, to improve your knowledge of the P42 so you can make a safe, on-time trip every time you make a run. So Lee and I thank you for giving us a few moments to introduce this video series. This is an essential part of Amtrak's investment into the future, an investment into locomotives and an investment in the most important asset the company has in you, our people.
The Amtrak P42 represents the latest technological advances in passenger locomotives. After viewing this program, the Amtrak P42 overview, you will be able to explain the P42's operating characteristics, identify the location and function of its operating controls, identify and locate the electrical control equipment, and identify the unit's major components and their role in the operation of the locomotive. Also, we'll be discussing the precautions that must be followed to operate the locomotive safely. We've divided this program into the 5 areas of the locomotive. They are the operator's cab, the auxiliary compartment, the engine compartment, the radiator compartment, and the exterior. We'll begin in the operator's cab. There is the engineer's control console, the center console, the assistant engineer's console, operator cab ceiling devices, operator cab equipment, and located behind the engineer, the engine control EC panel and Control Area 1. Let's take a closer look at each of these areas. The engineer's control console is fitted with the control devices that are used to operate the locomotive. The air brake controller is on the right side of the console. The automatic brake handle combines the function of controlling both the automatic brake and the dynamic brake when using blended braking. The system is designed to supply as much dynamic braking as possible, with the remainder of the required braking coming from the standard air brakes. Blended braking is prevented when the combined power handle is in a position other than idle, and when the brakes have been bailed off. The automatic brake handle operates through 6 detented control positions. They are release, minimum reduction, suppression, full service, handle off, and emergency. The service zone is between the minimum reduction and the full service positions. Release is selected when charging a train or releasing an automatic brake application. The handle position is closest to the engineer. The minimum reduction position provides a 5 to 7 pound reduction of the brake pipe pressure. Moving the automatic brake handle away from the engineer into the service zone increases the reduction. Suppression provides a 15 to 19 pound reduction. Moving the handle farther to the third raised position causes a full service reduction of 23 to 26 psi. The handle off position is for trail unit operation, push service operation, and when the unit is dead in tow. Moving the handle to emergency, the farthest position from the engineer, initiates an emergency brake application. The independent brake handle controls the application of the brakes on the locomotive only. To apply the independent brake, move the handle away from the engineer. To release the independent brake, move the handle toward the engineer. The independent brake should always be in the release position when the unit is in trail operation, when it is dead in tow, or when it is operating in push service. To make an independent release of an automatic brake application, pull up on the ring on the independent brake handle. You must hold the ring up for 4 seconds per locomotive in the consist to allow proper actuation to fully bail off the brakes on all the units. The brake pipe cutoff pilot switch is located below the independent brake handle. It performs the function of the brake pipe cutoff pilot valve. The switch has 4 positions. They are trail for operating in trail position in a multiple unit consist, in push service, or dead in tow. Test is selected when performing a brake pipe leakage test. The pressure maintaining feature is nullified when the switch is in test. Turning the switch to the freight or passenger positions restores control of the automatic brake. The freight and passenger positions are for instances when the unit is in the lead position. While the freight position provides a direct release of the brakes, passenger provides a graduated release of the brakes. The onboard computers may limit loading if the automatic brake is applied while the locomotive is operating in power mode. You must follow Amtrak's operating rules when using the brake system. Let's examine the power braking restriction and the logic behind it. The control system imposes restrictions to prohibit the excessive use of air brakes during motoring. Automatic limits are enforced by the control system in two different ways, depending on the position of the brake pipe cutoff pilot switch. The passenger operation restriction occurs when the switch is in the passenger position and there is a minimum automatic brake application or an automatic brake application beyond minimum brake for more than 30 seconds, when the combined power handle is in notch 5 or higher and the locomotive speed is 12 miles per hour or greater. If the unit is above notch 4 when the limits are imposed, throttle call is reduced by 1 notch every 4 seconds until notch 4 is reached. Load-limited too much power braking appears in the summary message area on the IFD screen. This condition resets after the engineer moves the combined power handle to notch 4 or lower and there is no brake application for 2 seconds. The freight operation restriction occurs when the brake pipe cutoff pilot switch is in the freight position and there is a minimum reduction for more than 3 minutes, when the combined power handle is in notch 5 or higher and the locomotive speed is 12 miles per hour or greater. If the unit is above notch 4 when the limits are imposed, throttle call is reduced by 1 notch every 4 seconds until notch 4 is reached. Movement beyond minimum reduction automatically reverts to passenger power brake logic. Load-limited too much power braking appears in the summary message area on the IFD screen. This condition resets after the engineer moves the combined power handle to notch 4 or lower and there is no brake application for 2 seconds. You should be aware that a traction motor stall condition can occur when the combined power handle is in notch 1 or higher and the traction motor speed is 0 miles per hour. If the brakes are applied for more than 10 seconds with the combined power handle in notch 1 or higher and the traction motor speed is 0 miles per hour, the computer restricts the alternator current. An alarm sounds for 5 seconds. The summary message area on the IFD screen displays, "Please move throttle to idle." The traction motor stall condition resets after the operator moves the combined power handle to idle for 2 seconds. The master controller is to the left of the air brake controller. The combined power handle controls locomotive load and dynamic braking effort. Moving the handle from idle toward the engineer gives you motoring from notch 1 through notch 8. Moving the handle away from the engineer through a gate takes the unit from setup, which connects the traction motors in series and connects their armatures to the grid resistors, into dynamic braking from DB1 through DB8. The position of the reverser handle determines the direction of locomotive travel. The selections are forward, centered or neutral, also called off, and reverse. The reverser may be removed in the neutral position. Remove it when the unit is going to be unattended, or if it is operating as a trail locomotive, in push service, or if it is dead in tow. When the reverser is removed, an interlock prevents the combined power handle from moving. Pressing the horn button, located on the engineer's control console only halfway, sounds the horn at 1/2 of its full volume. A full press allows the horn to sound at full volume. The horn and the crossing bell are interlocked, and both sound when the horn button is pressed. Additionally, pressing the horn button causes the crossing lights to come on and begin alternately flashing. The horn stops when the horn button is released. The bell continues to sound until the bell button is pressed, and the crossing lights continue to flash for 30 seconds. The lead axle sanding switch applies sand to the rail in front of the leading axle of the leading truck on the lead locomotive. The sand is applied at any speed. The sanding switch applies sand in front of the lead axle of each truck in the consist when the train is moving less than 7 miles per hour. Above 7 miles per hour, the sanding switch is disabled, and sanding is controlled by the onboard computers. The Acknowledge push button and the Alerter whisker switch both reset the alerter timer. To prevent a penalty brake application, any one of the following must occur within a set time interval. Either switch must be activated. The combined power handle or reverser must be moved. The automatic brake handle must be moved into or out of release. The bail-off feature must be activated, or the horn or bell must sound. The Acknowledge push button is also used to indicate that the engineer has recognized a downward change in cab signal status. Failure to respond to the cab signal status change also causes a penalty brake application. A clipboard is provided to help the engineer organize paperwork. 2 of the 3 integrated function display IFD screens on the Amtrak P42 are located on the engineer's control console. The IFDs are the primary method with which the engineer receives the information required to operate the train safely and efficiently. The locomotive's speed is displayed in both digital and graphical formats. An acceleration pointer or predictor calculates what the speed will be in 1 minute if operating conditions remain unchanged. The load meter indicates motoring and braking amperage in both digital and graphical formats. The air brake information zone contains air brake equipment operating pressure. Both the brake pipe pressure and the equalizing reservoir pressure are displayed in digital and graphical formats. The regulating valve setting is indicated by graphical triangles. Brake cylinder pressure, reduction pressure, last car pressure, and the main reservoir are displayed in a digital format. Operation warning lights illuminate if conditions outside the normal operating range occur. Fault messages are displayed identifying the problem area and explaining the trouble in more detail. Most operating functions are set up and controlled from the IFDs. These include cruise control, the electronic air brake regulating valve setup, and the end of train setup. System tests can be performed from the IFDs and status information is available. These tests include the cab signal test, the air brake departure test, the alerter magnet valve test, and the speed check. The update information includes the fuel monitor status and the distance counter. Pressing the full screen brightness push button next to the right engineer's screen restores all IFD screens to maximum brightness. The MU emergency shutdown push button switch shuts down all of the MU'd locomotives in the consist. The button must be set to the run position to restart the unit. The spotter push button is pressed to move a locomotive using only battery power, such as in a shop area. The diesel engine may or may not be running. The cab signal overspeed display panel has a warning light, a SON alert, and a selector switch. The front and rear headlight switches have 4 positions: off, dim, medium, and bright. If the train is equipped with a 2-way end-of-train device at the rear of the train, throwing the EOT rear emergency brake switch vents the brake pipe from the rear of the train at an emergency rate. The crossing light selector switch turns on the crossing lights in a non-flashing mode. The parking brake applied indicator informs the engineer of the parking brake status. The parking brake must be released before normal operation. The slow speed devices control the slow speed backing operations. These include the enabled indicator, the backing push button, and the backing excitation controller. Refer to the operator's manual for additional information on the operation of slow speed backing. The lower console contains additional operating circuit breakers. The engine run breaker must be on to control diesel engine speed. The generator field breaker permits control of the generator output. The control breaker provides power to train line control positive. The dynamic brake circuit breaker allows control of the dynamic braking output through the combined power handle. These breakers should be on for lead operation and off for trail operation. In push service, only the control breaker is on. The gauge light toggle switch is at the end of the row of circuit breakers. The window heater, the power limit switch, and the step light switches are located below. The power limit switch limits power to notch 7 on the lead locomotive. This function is not train-lined. The heater air conditioner control switch selects between various heater and air conditioner settings. The air conditioner control knob allows the engineer to set the temperature of the air coming from the heater and the air conditioner. The train line ground reset push button silences the electronic air brake alarm. This receptacle provides 74 volts DC. The gauge lights may be adjusted to compensate for lighting conditions in the cab. The floor-mounted horn sequencer switch integrated to the onboard computer system is operational when the locomotive is traveling above 1/2 mile per hour. One press starts the horn sequence that also activates the bell and crossing lights. The horn sounds 2 long, 1 short, and 1 long blast. The bell rings and the crossing lights alternately flash. Pressing the horn sequence foot switch again silences the horn. You must press the bell button to stop the bell. The crossing lights continue to flash for 30 seconds. The floor-mounted radio foot switch permits the engineer to use the radio when wearing a headset. The center console contains the HEP control panel, the radio, and handset. There is an emergency brake valve push button on the left side of the console. Pushing the button initiates an emergency brake application. To reset, you must pull out the button. Beneath the radio are the cab floor lighting switch that controls the lights that are located where the floor height changes, and the cab dome light switch. The cab signal aspect display is above this console. This unit displays the cab signal aspect as received electronically from the track. There is a switch on the top of the display that must be set according to the cab signal territory in which you are operating. The Qualcomm Train Communication Controller sends and receives data. Caution: the engineer must never access this device while operating the locomotive. The entrance to the nose compartment is located below the center console. The operating air to the front sand magnet valves may be cut out using the cutout cock located in the nose compartment. The assistant engineer's console is fitted with the unit's third integrated function display. Although it is used to monitor locomotive performance, such as measured mile, fuel monitor, the distance counter, and perform diagnostic tests, other operator functions are disabled. A horn button is to the left of the IFD screen. Below the horn button is the assistant engineer's headset station. A clipboard is built into the desktop. A radio handset for the assistant engineer is to the left of the console. A 110-volt AC receptacle is at the bottom of the left side of the console. Let's start back at the engineer's control console and look at some of the operator's cab sealing devices. A visor is provided to reduce the nighttime glare from the IFD screens in the side mirror. Above the engineer's area are the engineer's light controls, the engineer's desk light and switch, and the engineer's reading light and switch. The audio-visual alarm AVB box is located above the center control console. This device provides audible tones and flashing lights when the alerter, locomotive overspeed, or end-of-train device requires the engineer's attention. The area above the assistant engineer's console is fitted with desk and reading lights and devices similar to those above the engineer's control console. An auxiliary headset station and dome light are located in the center area of the cab ceiling. Operator cab equipment is located conveniently within easy reach of the crew members. The engineer's headset station is located near the bottom right wall of the operator cab. A first aid kit along the wall and 2 fire extinguishers, one behind the engineer's seat and one behind the helper's seat. Windshield wiper controls are mounted along the engineer's and assistant engineer's side walls. A push button activates the windshield washer. The parking brake controller applies and releases the parking brake. If there is no main reservoir pressure, the parking brake may be manually released after the wheels are chocked. The dead engine feature also can be cut in to release the parking brake if the brake pipe pressure is above 90 psi. The parking brake must be released before operating the locomotive. The auxiliary cab heater provides additional heating when required, such as during cold morning startups. The refrigerator, powered by 110 volts AC, functions when the head-end power is operating. There are 3 air conditioner heater vents in the operator's cab. In addition to a vent next to both the engineer and the assistant engineer, there is a vent above the EC panel behind the engineer's cab seat. The windows are tinted, and sunshades are provided to reduce glare to improve visibility and increase crew comfort. Mirrors help monitor train conditions. A fresh air damper allows the fresh air supply to the cab to be shut off in extreme weather. The dead engine cutout cock, the bell cutout cock, and the control air cutout cock are located beneath the operator's cab floor. Now let's turn our attention to the rear of the operator's cab and the EC panel. The EC panel contains the circuit breakers, switches, and other devices that must be set for proper locomotive operation. The top row of the EC panel contains circuit breakers. Turn on or off the required breakers for lead or trail operation. The top row breakers consist of the window heater circuit breaker, the cab signal circuit breaker, the satellite system circuit breaker, the road crossing light circuit breaker, the 74-volt DC radio circuit breaker, the 12-volt radio circuit breaker, and the front and rear headlight circuit breakers. The first device on the EC panel's second row is an engine stop push button, which shuts down the diesel engine on this unit only. The circuit breakers on this row must be on when the locomotive is operating in both lead and trail positions. They control the air brake computer, the 120-volt AC radio battery charger, the 120-volt AC receptacle, the air dryer circuit, the running lights, which includes all of the lights except the headlights and crossing lights, the marker lights, the fuel pump, local control, and the battery charge and computer. The engine control EC switch has 4 positions. Start completes the circuit in the starting system that enables the diesel engine to crank when the fuel prime engine start switch is turned to the start position. Isolate holds engine speed to idle. In this position, power cannot be applied to the propulsion system and the unit is considered off the line. Run should be selected when the engine is idling and the locomotive is going to be operated. Jog completes the circuit that enables the unit to be moved under battery power with or without the diesel engine running. The spotter push-button feature will not operate unless the EC switch is in the jog position. The MU headlight switch should be set according to the locomotive's position in the consist and its direction of travel. 5 additional switches control lighting on the unit. They are the control compartment light switch that provides light in control areas 1 through 5, the front and rear marker light switches, the front number light switch, and the engine room maintenance light. This light will only come on when head-end power or shop power is available. The traction motor cutout switches may be used to cut out 1 or more traction motors. Caution: always have the engine control switch in isolate and the combined power handle in idle before cutting out a motor. Always follow all Amtrak safety rules and regulations regarding traction motor cutout. Cutting out a traction motor affects the performance of the unit on which the motor is cut out. Power output may be reduced, and dynamic braking will not be available. The speed sensor cutout switch cuts out the speed sensor on any traction motor that is cut out. To ensure that wheel slip protection is retained, the speed sensor is only cut out if a traction motor cutout switch has been thrown. Use the switch only to eliminate a faulty sensor. First, you must determine that the wheel involved is not locked or sliding. The locked axle alarm cutout switch cuts out the locked axle alarm. Before using this switch to silence the alarm, determine that the wheels are rolling. The alerter, cab signal system, and overspeed may be cut out if the associated equipment is not functioning properly. However, you must follow all Amtrak regulations governing the use of these switches. The cab signal transfer switch selects between the cab signal system and the intermittent inductive train stop system. The Battery Connect push button is another device on the lower section of the EC panel. Since the P42 battery saver circuit disconnects the batteries 15 minutes after the diesel engine is shut down, use this push button to reconnect the batteries before you start the unit. Critical circuits continue to be powered even when the battery save circuit is engaged. The battery charging ammeter indicates current flowing into the batteries when they are charging and out of the batteries when they are discharging. The no battery charge light comes on when the battery charge circuit is inactive. Control Area 1, CA1, is next to the EC panel at the back of the operator's cab. It houses the computers that monitor the locomotive's operating systems and most of the locomotive's low-voltage operating equipment. The left side of CA1 contains control relays. Control circuits such as the MU shutdown system and control devices make up the rest of the left wall. They include the Intermittent Inductive Train Stop Controller, IITS, with its reset button. Current from the battery to all but the most critical circuits that must remain online flows through the battery switch. To start the locomotive, the battery switch must be closed. The middle area of Control Area 1 contains the control switch panel. Among the switches is the Auxiliary Alternator Field Cutout Switch, BFCO. This switch enables and disables the alternator field contactor. The fan reverse switch, a momentary contact switch, sends a fan reverse request. The backward rotation of the fan blades blows debris from the radiator fan inlet screens. The request is granted only if the reverser handle is centered. The onboard computers also share this area. They are the IFC, the cab, the X, the aux, and the HEP. The IFC processes the information it receives from various locomotive systems, such as the air brake system, and sends it to be shown on the Integrated Function Displays, IFDs. The permanent core memory records locomotive event data. This information is downloaded onto recorder hard cards through the custom record device CRD slot. The cab controller is the master processor. Its outputs are based on requests from the engineer, other onboard controllers, and the train line. X receives information from the cab controller. It also controls diesel engine loading while it monitors onboard generators and motors. The aux controller receives inputs from HEP, X, and onboard sensors for use in controlling auxiliary systems. The HEP controller controls the head-end alternator output and blended braking. The end-of-train monitor receives air brake pressure and data from the rear-mounted end-of-train device and sends the information to the IFC. The right wall of Control Area 1 contains additional circuit breakers, control devices, and control relays. The circuit breakers in this area include the 480B breaker, provides power to the locomotive's 120-volt AC outlets. Overcurrent protection for the devices is provided by their respective circuit breakers, the head-end power generator, the air conditioner heater unit, and the redundant battery charging panel. The hot bearing protection panel receives temperature signals from the traction motor support bearing temperature sensors on this locomotive only. Status reports are sent to the X controller. If a hot bearing is detected, a continuous alarm sounds and warnings appear on the hot bearing detection panel and the IFD when the unit is traveling above 10 miles per hour. Push alarm reset to silence the alarm. The alarm automatically stops sounding when the speed is reduced to below 10 miles per hour for 30 seconds. Follow Amtrak's rules and regulations regarding hot traction motor support bearings. That completes our look inside Control Area 1 and our tour of the operator's cab. The toilet compartment is conveniently located just behind the operator's compartment cab door on the way to the next area we will discuss, the auxiliary compartment. This area is an electrical compartment divided into 4 control areas. Warning: high voltage is present in this section of the auxiliary compartment when the locomotive is under load, when head-end power is provided, when battery charging is taking place, and when the radiator fan or equipment blowers are operating. The door interlock switch, DIS, is used for safety protection from high voltage in the auxiliary compartment. The door interlock switch opens with the door, dropping out the control contactors. The head-end power alternator, auxiliary alternator, and traction alternator unload. All high-voltage electrical power above 74 volts is removed. When entering this compartment, you should follow these additional safety precautions. Open the auxiliary alternator cutout switch BFCO on the control switch panel in CA1 before entering the compartment, and make certain that HEP is shut down on all of the units in the consist, as well as from a wayside source. Control Area 2 is on the right-hand wall past the rear of the toilet compartment. This panel contains cranking components, the computer power supply, and a variety of modules and relays. Control Area 3, directly across from the electrical compartment door, contains many of the high voltage and high current devices. The propulsion contactors include the power contactors P1 through P4 that connect the traction motor circuits, and the braking contactor that configures the traction motor fields for dynamic braking. The brake motor isolation switch, BS, connects the traction motors to the braking grids during dynamic braking and self-load. It also isolates the grids during motoring. The HEP lead isolate switch, LIS, removes power from the front-end HEP receptacles. The HEP transfer switch, HETS, connects either the head-end alternator or the traction alternator as a source of head-end power. The reverser, REV, changes the direction in which the traction motors turn, allowing the locomotive to change direction. Control Area 4 is on the left-hand wall as you enter the compartment. It contains the regulating panels. These panels take in 3-phase AC power and convert it to DC for use in the control systems. These panels are interchangeable. The alternator blower thermal overload device, ABOL, monitors the blower current and opens the circuit in the event of an overcurrent condition. The ABOL is equipped with a reset. The equipment blower panel, EBP, and the radiator fan panel, RFP, send out altered three-phase current to control motor speed. The two panels are interchangeable. Control Area 5 is on the right-hand wall as you enter the compartment. Now let's move on to the engine compartment. On our way, we want to point out the cutout cock for the horn. It's located down and to the right as you enter the engine compartment. Let's start with the power generation equipment. Power is generated by the alternator that consists of 3 alternator compartments: the traction alternator, the auxiliary alternator, and the head-end power alternator that are driven by the same shaft. The three-phase alternating current from the traction alternator is sent directly to the power rectifiers, where it is converted into direct current for the traction motors. The three-phase alternating current from the auxiliary alternator operates blowers and fans and provides battery charging and excitation. The three-phase alternating current from the head-end power alternator supplies power to the train. The engine start station is on the engineer's side of the locomotive next to the traction alternator. It contains the following pressure gauges: fuel oil, turbo air, and lube oil. A 3-position fuel prime engine start switch and an engine stop switch are on the same panel. Before starting the diesel engine, check all fluid levels and follow all railroad operating and safety procedures. After making certain that the battery switch is closed, that the MU push button is in run, that the BCPB has been pressed, that the EC switch is in the start position, and that all of the proper breakers are on in the operator's cab, the engine may be started. Move the fuel prime engine start switch to the prime position. Observe the fuel flow sight glass to make sure it is free of bubbles. The fuel pressure should rise to about 55 psi. After the pressure stabilizes, move the switch to the start position. After a 3 to 5 second pause, the engine begins to rotate. Hold the switch in the start position until the engine is running. With electronic fuel injection, there is no lay shaft. The fuel is metered automatically by computers in the EFI control system. Should you need to shut down the diesel engine, press the engine stop push button. The 7FDL diesel engine can produce up to 4,250 horsepower. Let's look at some of its many components. A single turbocharger mounted on top of the diesel engine is driven by the engine exhaust gases. It provides compressed air to the cylinders. 2 intercoolers lower the temperature of the intake air as it flows from the turbocharger. The computer-controlled electronic fuel injection has eliminated the need for a rack, its associated linkage, a governor, and a lay shaft. Proper engine operation requires a reliable lubricating oil system. The diesel engine oil level can be checked with a dipstick located on either side of the diesel engine. Next to the dipstick is the oil fill, used for adding oil. The engine must be idling for proper oil level readings. Oil pressure is monitored by the lube oil pressure sensor, and diesel speed is controlled to prevent damage. The pressure inside the crankcase is monitored by the crankcase overpressure sensor, COP. If the sensor detects an overpressure condition, a signal is sent and the diesel engine goes to idle. The cooling water system has a 210-gallon capacity water tank. Tank level can be determined by the water level sight glass. The tank can be filled through the radiator fill fitting when the radiator fill valve is in the open position. You must relieve pressure in the cooling system before adding water by opening the pressure relief valve. Caution: if the pressure cap must be opened, shut down the engine and relieve any pressure through the pressure relief valve. The cooling system is monitored by the engine water temperature sensor, EWT. It sends water temperature data to the aux controller, where it's used to determine radiator fan speed control and other functions. A drain valve in the sump allows for system draining. The combustion air system delivers cool, clean air to the power assemblies for combustion. The filtration system consists of V-screens, spin filters, and baggy filters. Summer-winter doors are manually operated to provide air from the engine compartment when air intakes are blocked with ice or snow. Caution: summer-winter doors must remain closed when the outside temperature is above freezing. An engine air filter pressure switch, EFPS, monitors the condition of the baggy filters. It sends a signal to the cab controller. The pressure and temperature of the intake air is monitored by the manifold air temperature sensor and the manifold air pressure sensor. The fuel oil system delivers diesel fuel to each power assembly. Under normal operation, fuel is drawn from the tank through a preheater and its automatic temperature valve by the fuel transfer pump. It is sent through the fuel filter. From the filter, the fuel goes to the supply lines to the high-pressure pump on each cylinder. Fuel flow control valves are located on either side of the engine cab. A fire extinguisher is also located in the engine cab. Those are the engine compartment components. Now let's look at the radiator compartment and its subsystems. We'll begin with the electrical equipment cooling system. This equipment blower assembly provides cooling air to the traction motors in the rear truck. The filtered air is forced into the traction motors. Dirty air from the filters is exhausted into the radiator cab by the exhauster blower attached to the equipment blower. The air compressor is AC motor driven. It is designed to provide near optimum train charging with the diesel engine running at idle. The air compressor must be off before checking or adding lubricating oil. The local control circuit breaker located on the second row of breakers on the EC panel must be turned off before performing either procedure. The oil dipstick is used to determine lubricant level. Oil may be added through the fill cap. The cooling system maintains a nearly constant engine operating temperature with a pressurized wet radiator system. 2 radiator sections are used, and they each have their own shutters. The radiators are cooled by a single fan that is controlled by the radiator fan panel. The rear sander cutout cock is inside the radiator compartment beneath the sandboxes. Control Area 9 houses the air compressor drive contactors and the traction motor blower sensor. The entrance to Control Area 9 is protected by a door interlock switch that opens with the door, dropping out the control contactors. The air compressor control panel is next to Control Area 9. The panel houses the air compressor control devices and the shutter control valves. The compressor governor switch, CGS, provides an input signal to the X controller for the operation of the air compressor. The compressor magnet valve is used to load the air compressor during pumping operation. The compressor cutout cock is used for maintenance. Extra equipment found in the radiator compartment includes a basic toolbox and, as an additional safety feature, a fire extinguisher. The short hood or front end of the Amtrak P42 is fitted with the latest, most advanced locomotive lights available to improve your visibility and help you to be seen by others along the right-of-way. There are twin front headlights, crossing lights, marker lights, and number lights. The electrical connections are color-coded for easy identification. The locomotive control MU connection has a black jumper and a black receptacle. It is the railroad standard train line multiple unit 27-pin jumper. The communications MU connection has a blue jumper and receptacle. This line is used for communication between the locomotive and the passenger cars. The head-end power connections for the left and right side have red jumpers and receptacles. These carry the 480-volt 60-cycle AC power to the passenger cars. The air MU connections are also standard railroad connections. They are the brake pipe, main reservoir supply, main reservoir equalizing, actuating, independent application and release. Sand fill boxes are located on both sides of the locomotive, behind flush mount body doors. Sand traps are at the bottom of each sand box. The couplers are AAR Type F and are configured for uncoupling from either side of the locomotive. The uncoupling mechanism is located behind the snowplow. The cab signal inductive coils are mounted behind the front pilot plate. They receive cab signal information. The air brake compartment is located on the right side exterior. The air brake compartment houses the Knorr electronic air brake equipment. It is designed to provide the latest electro-pneumatic control over the air brake system while maintaining the same functionality of conventional 26L equipment. The New York Air Brake Knorr pneumatic control unit provides the air portion of the electronic air brakes. It is important to have clean, filtered air to help cool the locomotive equipment that is sensitive to excess heat. The right side of the Amtrak P42 is fitted with air intake screens. The dynamic brake air intake screens are mounted directly behind the right side front entrance door. The equipment blower air intake, the combustion air intake, and the radiator air intakes are filtered through V-type screens. The 2,200-gallon fuel tank has a fill rate of 300 gallons per minute. The fuel tank on each side of the locomotive is divided into two compartments, front and rear, for a total of 4 separate compartments. Each compartment has a supply and return shutoff valve. These valves must be open during normal operation. If one of the fuel compartments is leaking, ensure that the other compartments have room to accept the fuel from the leaking compartment. Close the return valve to the leaking compartment. Close the supply valves on the other compartments and run the fuel pump until the leaking compartment is empty. When the leaking compartment is empty, close the supply valve for that compartment and open the supply valves to the other compartments. 3 digital fuel gauges are provided, one on each side of the locomotive and one in the radiator cab. The fuel level also appears on the integrated function display. The level displayed is approximated by adding the amount of fuel in the right front and the left rear fuel compartments and multiplying it by 2. 4 circular fuel level sight glasses are provided for each of the 4 fuel compartments. Remember, emergency fuel cutoff switches are provided on each side by the fuel fills at the diesel engine start station and on the EC panel in the operator's cab. The Amtrak P42's trucks and suspension system were designed specifically for the new Amtrak fleet of locomotives. The locomotive frame rests on 4 secondary springs located on each truck. The truck frame rides on primary springs that are seated over each journal bearing housing. The bearing at each end of each axle transmits the weight of the locomotive to the rail. Axle snubbers help reduce spring oscillations. Horizontal, lateral, and vertical snubbers are provided for improved ride control. Tie rods connect the bearing housings and provide force transfer equalization. A unitized Knorr parking brake unit is provided that incorporates a spring-applied, air-released parking brake. A special tool is provided to enable you to operate the manual parking brake release handle by hand. The sand brackets and pipes are attached to the truck frames. Let's look at the air brake system components on the right side exterior of the Amtrak P42. The number 2, or right side main reservoir, is located directly behind the number 2 main reservoir final filter and the auxiliary air final filter. The brake cylinder cutout cocks and the parking brake cutout cocks are located on the right side of the locomotive. One of each can be found near both trucks. All cutout cocks are labeled on the car body. One of the battery boxes is located behind the fuel tank. The other is located on the other side of the locomotive. The toilet drain is mounted behind the lead truck. 3 locomotive entrance doors are located on each side of the locomotive. One leads to the operator's cab. Another takes you to the radiator compartment. The 3rd access door used for engine servicing is at the engine compartment. When entering any door, you must remember to place your foot firmly on each step, including the top step, to avoid injury. Caution: do not ride on the operator cab steps while the locomotive is moving. The horn is mounted on the roof above the alternator. There are 3 antennas, one for the Qualcomm system, one for the voice radio, and one for the end-of-train device. The exterior lights and markings on the number 2 or rear end of the locomotive consist of the rear headlights, the marker lights, and the decal. The number 2 end has the same electrical multiple unit connections as the front or number 1 end. The locomotive control MU connection has a black jumper and black receptacle. The communications MU connection has a blue jumper and receptacle. The head-end power connections for the left and right side have red jumpers and receptacles. The air MU connections are also standard railroad connections. An entrance door located at the rear of the locomotive allows passage between units. The fill ports for the two rear sandboxes are on both sides of the rear entrance door. Much of the left side exterior of the Amtrak P42 is identical to the right side. Here we find the number 1 or left side main reservoir. The twin tower air dryer used to condition the air is located in line between the number 1 and number 2 main reservoirs. Cutout cocks are located on each side of the twin tower. There are a couple of areas that are unique to the left side of the locomotive. Caution should be used around the dynamic brake exhaust vent. Hot air is present during operation such as self-load and dynamic braking. The last component we come to in our overview is the heater air conditioner unit. It is mounted under the cab floor on the left side of the locomotive. Well, that completes our overview of the new Amtrak P42 locomotive. We hope that you've enjoyed discovering what's new about this powerful addition to Amtrak's fleet. With the continued support of both the operating department and the mechanical forces in maintaining Amtrak's high standards of operations and maintenance, the new P42s will provide many years and millions of miles of service.